Hello, I'm Barry Marshall at the University of Western Australia in Perth. You might recall I won the Nobel Prize for the discovery of the bacteria which causes ulcers, Helicobacter, in 2005. Today I'm giving a short, tongue-in-cheek presentation about that discovery for Biofest in Madras in 2014. So our first slide, which is the title slide, just shows you the University of Western Australia. And I hope you all can visit and perhaps do some study here at some time in the future. Now, the title of my talk today is going to be Secret Stuff About How to Win the Nobel Prize in Physiology or Medicine 2005. Actually, this applies to any Nobel Prize, and I'm going to give you some very good examples of how you can do it the easiest way possible. So I'll talk about my own discovery first, and this is going to be about Helicobacter and how you say the name of the bug. It's very simple. It really sounds like helicopter. So helico means spiral, Helicobacter means spiral bacteria, and pylori means it's found at the pylorus, which is the lower end of the stomach that holds the pyloric sphincter. Now, before I commence about my own discovery, I want you to listen to a little story about at least one of my favourite Nobel laureates, actually two. The first of my favourite Nobel laureates is actually Einstein. And the interesting thing about his discovery is that it was a new interpretation on someone else's data. So he didn't even do any laboratory work. He was just thinking about something that everybody knew. And he suddenly realised that he had a new hypothesis, a new explanation, and that was relativity. So what was that discovery or other data that he knew about? Well, that was the experiment by Michelson-Morley about 30 years before. And they had studied the speed of light at different times and in different directions on the Earth. So if you imagine that the Earth is traveling around the Sun, as we've shown here, you'll see that if you shine a light in the same direction that the Earth is traveling, if you shine it in the same direction 6 months apart, you should get different results, because supposedly the Earth's traveling through space, and in space was the luminiferous ether, which was supposed to be some invisible thing which was carrying light rays. Well, anyway, what happened was that Michelson and Morley could never find any difference in the speed of light, so they assumed there must be something wrong with their apparatus. And it was very difficult to explain their results. They repeated it many, many times, but really got nowhere. So Einstein was walking his dog and he's thinking, oh well, speed equals distance divided by time. So if speed is always constant, maybe time is changing, because time equals speed over distance. So you could actually just rearrange that little formula and you could say, time is relative and speed is relative, and maybe even distance is relative. So he ended up discovering the theory of relativity. He came up with this idea that the speed of light was constant, nothing could go faster than the speed of light, and ultimately E equals mc squared. So that was Einstein's discovery, and it was so radical they did not actually give him the Nobel Prize for discovering relativity. They gave him the Nobel Prize for something else, but in fact this was his greatest discovery. So in summary then, Einstein discovered relativity in a mind experiment after contemplating the findings of other experimenters. So this is the kind of Nobel Prize you want to win. Very, very easy, no work involved, you're just thinking about something else and you come up with this idea. The second one I'd like to tell you about, and you'll know about this if you do any biotechnology, was the discovery of the polymerase chain reaction in 1983 by Kary Mullis. And the same kind of thing happened. He discovered the PCR in a mind experiment while driving his sleeping girlfriend in his sports car. So he had the right, so he was happy, cheerful. It was the weekend. He was taking his girlfriend out for a nice drive in the countryside in Los Angeles. And he started thinking about the work that he was doing in the Cetus company at that time in California. Let me just tell you a little bit about Kary Mullis. So here's the Nobel Prize citation for Kary Mullis and Michael Smith. Michael Smith is since deceased, but he had another DNA discovery oligonucleotide-based site-directed mutagenesis, so that was important. And Kary Mullis was for his invention of the polymerase chain reaction method. Here's another picture of Kary Mullis. He still lives in San Diego, and he goes surfing, and he wrote a very interesting book called Dancing Naked in the Minefield, which you should read. Very, very funny. So here's the description from Kary Mullis's book about the discovery of PCR. We were at a mile marker, 46.58 on Highway 128, and we were at the very edge of the dawn of the age of PCR. So all of a sudden he realized he could duplicate DNA, and he would get 1 billion copies after 30 cycles, and all he had to do is put excess reagents in the tube and heat and cool it. So he was pretty excited. He stopped the car, he wrote it down on a piece of paper. His girlfriend complained that he was waking her up. He got back in the car again and he drove further down the road. About a mile down the canyon he pulled off again because he'd made the second discovery important for the PCR reaction. And here he says his mind exploded again. A new and wonderful possibility. Not only could I make 1 zillion copies, but they would always be the same size. That was important. That was the almighty, the hallelujah clincher, the hell with Jennifer. I had just solved the 2 problems of DNA chemistry, abundance and distinction. So if you can make 1 billion copies of the DNA and they're all exactly the same size, it's very easy then to see them on a gel. You can separate them out, sequence them, etc. So he realized how important it was. Now, again, obviously Kary Mullis was a pretty brilliant chemist and had been thinking about the DNA for a long time, for a few years actually. But how long did it take him to make his Nobel Prize winning discovery? Well, Saturday afternoon when he was driving in his car, he thought of it. He went back to the lab, did a couple of confirmatory experiments on Monday afternoon, and there it was, the Nobel Prize discovery. So Nobel Prizes don't necessarily happen because you've done a lifetime's work which is very, very incremental. I think they happen because you had an inspiration and you suddenly see something where other people didn't notice. So getting back to my own story there, here I am with Dr. Warren in 1984. And that was after we had started the Helicobacter work, and there I am on the left. I was a trainee fellow in internal medicine, training to be a physician, but I was interested in microbiology and the sciences, so I was not really well differentiated. And the other thing was that I was not yet a gastroenterologist, so I had not been taught all this incorrect dogma about what causes ulcers, namely stress. We now know that stress is not true and pretty unimportant in many of the medical diseases. But when I was being trained, everybody told me that ulcers were caused by stress. It was psychosomatic or genetic. There was nothing you could do about it except give the ulcer treatment, which I'll talk about in a second. And on the right there we have Dr. Warren looking down his microscope, seeing these spiral bacteria, which we now call Helicobacter. So he saw them, but as a pathologist he couldn't easily communicate with the patients and see their diseases, etc. So I teamed up with him to find out what these bacteria were doing. And we were very interested in them because, of course, how could bacteria live in the stomach? Every medical book said that the stomach was sterile because it's full of acid. So we all like to prove everybody else wrong and say, aren't we so smart? So Warren and I were exactly the same, and we just wanted to publish a little paper saying, aha, bacteria can live in the stomach. Now, a couple of interesting things helped us. We searched the literature and we read very widely around our subject. We read veterinary journals, all kinds of things. And eventually we came across this paper by Giulio Bizzosero in 1892. He was an anatomist, and he was famous already because he had discovered that all dividing cells must have a nucleus. Even red cells in the marrow had nucleated precursors. So he was already famous. But the fine print of his theses or papers was that acid-tolerant spirochetes live in the dog's stomach. So 100 years before our discovery, people who knew Giulio Bizzosero would have been able to see these spiral bacteria in the acid-secreting stomach of the dog, and we now know a lot more about these, but here's an illustration. And here you see the curvy pink bacteria inside the acid-secreting cells, inside the canaliculi, where they are exposed to a pH of about 1.2. So even 100 years ago, if you knew that literature, you knew that bacteria could live in the acid-producing cells, and the bacteria therefore must be acid tolerant, or else they must turn off acid. And we now know Helicobacter can do both of those things, but it was an interesting finding. So Warren and I were pretty confident that we would be able to find out some interesting things about these human bacteria, and this observation of bacteria in the stomach in the presence of acid wasn't just a coincidence or an accident. These bacteria were actually living there. So let me remind you what peptic ulcers are, and here you see on the left a duodenal ulcer, on the right a gastric ulcer. Obviously it's an ulcer usually about the size of your thumbnail, and if it's in the duodenum it's called a duodenal ulcer, which is on the left, and they're very dangerous because you have big blood vessels, arteries underneath the duodenum, and if the ulcer goes through into an artery, quickly you can bleed to death just in a few minutes or a few hours. So not everybody with ulcers even has pain in the stomach. So you could be perfectly well one day, and in the middle of the night you could just die from bleeding from a duodenal ulcer. So it was a serious disease. Millions of people had it. In Western countries, 10% of the whole population would experience a peptic ulcer, either duodenal or a stomach gastric ulcer at some time in their life. And there were certainly a lot of people disabled by this problem, and a lot of people used to die. So in our hospital, probably there would be 1 or 2 people every week that would die from an ulcer in Western Australia, who may or may not have known about their ulcer before. So on the right hand side you see a gastric ulcer, and above that you see a picture of the stomach where these ulcers are commonly located, really not too far apart. And in fact, gastric ulcer, as it gets lower in the stomach, is really continuous with a duodenal ulcer in the first part of the small intestine, which is the duodenum. So there you are, and everybody thought that ulcers were caused by stress. The idea being stress causes too much acid in the stomach, and then eventually you get an ulcer. And that's why ulcers were so incurable, because it's your personality. You can't fix that, and you just have to put up with it for the rest of your life. And even if you were a very successful person, you might be the Prime Minister, you might be Bill Gates, somebody like that, having a very successful life in business, making lots of money, and all of a sudden you get an ulcer and your doctor say, oh, you have to quit what you're doing and retire, take holidays for the rest of your life, and just do nothing and eat very, very bland food, no spicy food, lots of stuff like boiled fish, boiled rice, very uninteresting food for the rest of your life, because otherwise the stress will cause an ulcer. So you can see what a terrible diagnosis it was if you were a normal person who liked to be a little bit active and not bored. I know that India is one of those countries where people really do have severe ulcer disease. We now know that it's caused by Helicobacter, but in those days, in India, everyone had different theories. Stress, bad diet, spicy food, who knows what it was, but not bacteria. So this was such a big problem. You can see that if you discovered the cure or a drug for it, is really going to be a big seller. And so this bred the world's first blockbuster drugs. A blockbuster drug is a drug which sells more than $1 billion in sales per annum. And the first drugs were the acid blockers. Here you see a World War II bomb which was weighing about 2 tons, and that was called a blockbuster. So the first blockbuster drugs were histamine receptor antagonists, H2 blockers. First one being cimetidine, the other one after that Zantac in the 80s. And together they used to have sales of $5 billion per year. So even 1983, 1984, when we made our discovery, those drugs were already selling $2 or $3 billion a year, and every person with an ulcer was taking them. But they didn't cure the underlying problem, which we now know was Helicobacter. It was just that they would reduce the acid level, the patients would feel better, and the acid would go down, and the ulcer would gradually heal. But as soon as the patients stopped taking the drugs, the ulcer would come back. So you see, at least it was a temporary cure, but really the patients were going to be on those drugs for the rest of their lives, at least $2 a day. So $1,000 a year in America, for example. And so they were fabulous. They were terrific products for the drug companies, because once they had a patient on ulcer treatment, they were going to be getting $2 off that patient for the rest of his life. Total $10,000 or $15,000 off each patient. So that was great. And of course, many people couldn't afford the drugs. So that was the H2 blockers, and that was the situation. And so you can imagine now you've got these two young doctors doing their first research and trying to publish a paper about a new discovery. Bacteria might be the cause of ulcers. And on the other side of the equation, if you like, millions of people taking these very expensive drugs, creating a giant pharmaceutical industry that was not interested in finding a cure. Because if they were going to sell the patients a cure, they could only sell it once. But if they sold the patient a treatment, they were going to be selling that treatment to the patient for the rest of his life. Much better business. So Dr. Warren and I started looking at patients at Royal Perth Hospital in Western Australia to see if they had these bacteria, and we passed the endoscope on a whole series of about 100 patients to look in to see if they had the bacteria and what other disease did they have. And this is a summary of our data, and you'll see that in 100 patients we had 13 patients with a duodenal ulcer. All 13, 100% of those 13 patients had Helicobacter. And if the patient had a gastric ulcer, 18 out of 22, 77% had Helicobacter. Whereas overall, on average for all our patients, only 50% had the Helicobacter. So we discovered two things there. The Helicobacter was very closely associated with ulcers. It didn't prove that they caused the ulcer, but they were very tightly associated. In fact, it was almost impossible to get a duodenal ulcer, we thought, if you didn't have Helicobacter. So the extrapolation for that, if you treat the Helicobacter with antibiotics and get rid of it, maybe you wouldn't be able to have an ulcer anymore. You would be cured. The second thing that was very confusing for us was that about 50% of the patients, even if they didn't have an ulcer, had the bacteria. So there were certainly people who had Helicobacter had no symptoms. But we didn't want to focus on them at the moment because the really hot topic was going to be the ulcers. So when we tried to publish this paper, I asked you the question, would the world accept the new cause for ulcers on the basis of data from only 13 patients? No way, it wasn't going to happen. And here's a picture of our letter we got back from the Australian Gastroenterology Society when we submitted our paper for a poster or an oral presentation. They said, Dr. Marshall, your research paper was not accepted for presentation. The number of abstracts we received continues to increase, and for this meeting 67 were submitted. We could only accept 56. So that means that they thought our paper was one of the worst, in the bottom 20%. So we were very frustrated and rather sad, and it took us a long time to get that paper published. However, things moved on. We needed to prove that these bacteria could infect healthy people, because everyone was saying to us, hey, these bacteria are just harmless, they're just there by coincidence, and the ulcer comes first and then those poor people catch the bacteria. So Dr. Marshall, stop wasting your time on these. And we said, well, you know, if we could show that these bacteria could just infect healthy people, then maybe we could actually go on and show that the bacteria came first and then the ulcers developed afterwards. So we tried to infect an animal, a pig, with these bacteria. We couldn't do it. So we said, we're going to actually have to do an experiment on a human. And so that happened in my lab in 1984. And here's a comic strip produced by the Abbott Company. Abbott Company makes many of the antibiotics used for Helicobacter treatment. So in this comic you see the picture of me and my lab tech Neil. He says, Dr. Marshall, you're crazy. And I said, there's no other way. And the only animal model I could see that was going to be any use was actually a human, and that was going to be myself. So I drank a culture of these bacteria, 10 to the 9th Helicobacter bacteria, and waited to see what would happen. Now, I did actually get infected, I'll tell you that in a minute, but I published a paper, an attempt to fulfill Koch's postulates for Campylobacter pylori, and that was the name of the paper, Medical Journal of Australia, 1985, and that was my hypothesis about how these bacteria would infect you and cause ulcers. So here's from the comic strip. I'm feeling unwell, and after a few days I started vomiting, but here I am, the deed is done, and I discovered that acute H. pylori infection can make you feel unwell. And so how come those ulcer patients didn't remember when they caught the bacteria? Well, it might have been because they caught it when they were such small children and they had it in their stomach their whole life and didn't notice it was there most of the time. And so here I am having an endoscopy after a couple of weeks, and Dr. Warren's looking at my stomach. He says, Dr. Marshall, your stomach is dangerously inflamed. And here you see under the microscope we're seeing these little curly black bacteria on the surface of my stomach cells. So I had a very heavy infection with Helicobacter, and after a couple of weeks I got rid of it now with various means. So what I showed was that the bacteria came first, and sometime later you would develop an ulcer, which meant that luckily for everybody now, you should be able to treat ulcers with antibiotics, and certainly that's what is happening around the world. In India, so many people have Helicobacter that it's very difficult to treat everybody, so it's more important to try and raise the standard of living, have everybody understanding proper hygiene principles, have clean drinking water, and proper sewage and sanitation. That's going to do more for Helicobacter in India than antibiotics for the whole population. However, when we do see a patient in India with an ulcer, great news, we know that antibiotics is probably going to cure him or her. Just a final couple of slides now. The good thing about Alfred Nobel's will, where he left all his money to the Nobel Prizes, he said the interest shall be annually distributed in the form of prizes, so it's millions of dollars now, to those who in the preceding year shall have conferred the greatest benefit on mankind. It's a bit hard to figure out a Nobel Prize in just 1 year, so it usually takes 10 to 20 years before someone wins the Nobel Prize and everybody accepts that it's an important discovery. The great thing, if you're in India, is that it's an international award. He said, in awarding the prizes, no consideration be given to the nationality of the candidates. The most worthy shall receive the prize, whether he be Scandinavian, in other words Swedish, or not. So the Swedish people were a bit annoyed at him leaving all his money to everybody else, they thought, but it turned out for the best. So one of the questions people ask me is, how come it took 23 years before you and Dr. Warren won the Nobel Prize? And I say, well, maybe the Swedish Academy at the Karolinska Institute had a secret agenda. And I'll just remind you that Robert Koch first cultured the tubercle bacilli, the cause of his Nobel Prize, in 1882. So here's some coincidences. 1882 he cultured TB. 1884 he described those experiments called Koch's postulates. And then in 1905 he won the Nobel Prize for discovering tuberculosis bacteria and the tubercle bacilli. So is it a coincidence? In 1982, that was the 100th anniversary, and we cultured Helicobacter for the first time in that year. And then in the 100th anniversary of Robert Koch's postulates being described, we did the experiment where I drank the bacteria and fulfilled Koch's postulates. And so we think maybe the Swedish Academy liked to wait for the 100th anniversary of Robert Koch's Nobel Prize before they awarded Dr. Warren and myself the Nobel Prize in Medicine for the discovery of Helicobacter pylori. In my second last slide, here are the secret hints for winning the Nobel Prize. Work hard, read widely around your subject, and find new explanations for other people's data. Keep a balance in your life. You need a sustainable effort which might take many years, so you don't want to burn out at a young age. And finally, always be kind to Swedish people. And in the final slide here is the Nobel ceremony photograph. In the back left-hand side, you can see Dr. Warren talking to some friends, and in the foreground, I'm giving the medal to my wife, Adrienne. Thank you.